Okay, guys, good morning again. Let us look at these two theorems. So this one is a continuation of theorem 5, which is about the cyclic quad. It's a continuation. Remember, I said there are three theorems that are involved on the cyclic quad. So this one is a continuation of theorem 5. So I'll explain the two theorems which falls under theorem 5 and the converses. Ne? And then after that, I'll stop there. And then tomorrow we'll be looking at the last theorems for the Euclidean geometry. Ne? So today we're looking at this one. Look at this one. This one says this. Remember here, I'm showing you the theorem, and I'm showing you how to answer the questions using this theorem. I'm not proving where the theorem is coming from, or I'm not showing where the theorem is coming from. So there is a difference. So using the theorem to answer questions is not the same as proving where the theorem is coming from. This one, we say this. We say, if you are looking at this, I have quad P M R. I have quad P M R N. Yeah, quad P M R N. So this is a quadrilateral. So this theorem applies on a cyclic quad. So we are saying PMRN is a cyclic quad. So this theorem says this exterior, remember exterior is an angle that is outside. This exterior angle, remember this exterior angle is formed at this point. So you have this side, which is the chord NR, and then you have the chord MN. So at this point. So we are saying this angle will be equal to that one. So I won't show you where this theorem is coming from for now, but this one is easy. You can prove it on your own. Okay. So, but for you to have this theorem, there must be a side of a cyclic quad that extends outside of the cycle. So for example, you see side MR. Side MR starts from here, and then it goes, and then it never stops here, but it extends outside. So you must have a side that extends out. So we have an exterior angle. We say an exterior angle of a cyclic quad is equal to the opposite interior angle of a cyclic quad. So which means here I can say angle R1 is equal to, this angle R1 is equal to angle P, is equal to angle P. And then the reason that we write here, we just say it's an exterior angle of a cyclic, this is why, exterior angle of a cyclic quad. Okay, so basically the reason in full should say exterior angle of a cyclic quad is equal to the opposite interior angle. But if we normally write it in a shortened version like this, we just say exterior angle of a cyclic quad, we are done. Okay, so even here, if you are looking at this one, you can see I have G, this is G. So I have a cyclic quad A, G, F, B. It's a cyclic quad because we have this corner and this corner and this corner and this corner touching the circumference. So 4 corners are touching, so it's a cyclic quad. So it means this angle G2. Remember this side which are connecting here, which is mean these chords. So from this chord all the way to this one, and from this chord all the way to this one. We don't look at the angle. We don't look at this one. So we have to look at. So I normally say place a ruler like this to check an angle that is opposite G2. So angle opposite G2 will be this one. Yeah, so which means angle B is equal to G2. So we are writing here angle G2 is equal to angle B, and then we write the reason. The reason is an exterior angle of a cyclic quad. Exterior angle of a cyclic quad is equal to the opposite interior angle. Okay, so the diagrams may differ now depending on the situation. Okay, and then I wanted to explain, look at this one, look at this one. So this one is not the same as this one. Okay, so this theorem applies only when there is a side on the cyclic quad, a side that extends outside of the cycle. Just like here, I have this side which is AG. So AG extends outside of the circle. So I can even use AG extend outside of the circle. So there must be a side from these four sides. Remember, I have 1, 2, 3, 4. So for you to have this theorem, there must be a side that extends out. So even here, if I like to, I can say angle A1, let me do this. Angle A1 is equal to, we can place a ruler like this, is equal to angle F. So it's the same reason. So you can say, let me write it here, angle A1, which is this one, will be equal to that one. Remember, you don't check the angles that are connected to these two. So you have to check another lines. So it's the angle that is made by these two. So don't check these two lines, these ones. So you check this one. So this angle and that one are equal. So angle A1 is equal to angle F. And then the reason you say it's an exterior angle of a cyclic quad. So it's a shortened version. We allow you to write it like this. Okay. Let me come back here now. So for those that want to see, but I'll take a photo of this and send it. So it's fine. So if you look at this one now, okay. So with this one, you can see I don't have a side that extends out. Although I have A as the point on the circumference, I have P as the point on the circumference, I have G as the point on the circumference, I have F. But this side PG doesn't extend out. So this side, for you to have this theorem, this side, at least this side here, you see this side must extend outside. So one side of the cyclic quad must extend outside. So this line here is not coming from any side. Okay, it's not extending out from any side. It's just a line. So which means this theorem won't apply here in this diagram. So the theorem won't apply here. And then we come back to this one. Look at this diagram, this one. So with this one, so let me create a question now because I've been showing you the theorem without creating a question. I can do this. I will say this one is 120 degrees. And then I say, yeah. So my question will say find, I'll show you the question in a moment. Find angle V2 and angle V1. Okay, so here's it. Can you see? So this question is for this diagram. So they are saying find angle V2 and then find angle V1. So to find angle V2, we know that this is a cyclic quad because V, F, L, Q are touching the circumference. So if they are touching the circumference, it means these four corners are touching the circumference. Hence, you have a cyclic quad here, okay? So for you to find V2, I can use the previous theorem that we did to remember that to say opposite angles of a cyclic quad are supplementary or they add up to 108. So which means if this one is 120, this one, what's it short for us to get 180 here? We are short of 60 here. So which means V2 is equal to 60 degrees. V2 is equal to 60 degrees because this one is 120. So when I add 1, 2, they must give me 108. Remember, opposite angles of a cyclic quad. So I can write it like this if I want to and say V2, angle V2 plus angle L, they must give me 180 degrees. The reason we are using the previous theorem, we say opposite angles that are facing each other. Opposite angles of a cyclic quad are supplementary. Okay, opposite angles of a cyclic quad are supplementary. And then you'll have angle V2 plus angle L is 120. So I'm just substituting there, equal to 180 degrees. And then angle V2 will be equal to 180. I'm transposing 120 to that side. Okay, so which means this will be 180 minus 120 degrees. So which means angle, let me write it a little bit, yeah. So angle V2 will be equal to 60 degrees. Yeah, will be equal to 60 degrees. So this angle is equal to what? 60 degrees. Okay, V2, angle V2 is equal to 60. So what you can do, you can just write angle V2 is equal to 60 degrees and then you write this reason. You'll get all the marks. You just say angle V2 is equal to 60 degrees and then you write this reason. And then after that we got angle V2, okay? So you'll get a mark and then you get a mark for the reason, okay? So it's 2 marks, okay? And then after this, look at this one. So I'm saying if you are placing a ruler, now I'm looking at this one, they want V1. So according to the equation, they want V1. So to get V1, there are 2 ways. So let me start by using this one. We know that V1, this one is inside and this one is outside. So an exterior angle of a cyclic quad is equal to the opposite interior angle. So I can just say straight away there to say angle V1 is equal to 120 degrees. So I'm using this theorem that I'm explaining here. So it says an exterior angle of a cyclic quad is equal to the opposite interior angle. But now to write it in a shortened version, you say V1 is equal to 120 degrees because it's an exterior angle of a cyclic quad. It's an exterior angle of a cyclic quad, and then you are done. Okay, someone can also use a straight line to say if this one is 60, obvious this one can be 120 because 120 plus 60 is 180. You can still use a straight line there, another method. So that is the application of this theorem. It's how we apply it. Okay, and then this theorem only happens if you have a cyclic quad. If you have what's a cyclic quad. So if you have a cyclic quad, you will have this theorem to say the exterior angle of a cyclic quad is equal to the opposite interior angle. But remember, we are saying for this theorem to apply, there must be a side on the cyclic quad that extends outside of the circle. So this side, which is in this case, which is FV. So FV extends outside. Unlike in this diagram, you don't have a side that extends out. This line just comes from this point to this one, this line. So here the theorem won't apply. So here you must have a side that extends outside of the cycle. So hopefully I'm making sense. Okay. And then after that, when I'm done explaining this, I want to look at the converse. There is a converse theorem. So a converse theorem says this. It says if this angle and this angle are equal, it will mean that VQLF is a cyclic quad. So this is what I'm talking about. Let me show you something. Look at this one. So here with this diagram, I can do this. So I can ask a question to say, let me write number 1 there. So I'm writing a question. Remember, when you won't have to write the questions. For me, I'm writing the questions because you don't have the questions here. But when you don't write the questions, they will give you the questions. I'm just writing the questions so that you see which questions are asked here. So when you won't have to create your questions at any moment. So you won't. So here, the question that I'm going to ask here is to say, prove that TR, which means TRFQ, is a cyclic quadrilateral. Is a cyclic quadrilateral. So you are proving, okay? So this is the question. So to answer this question, I can answer it in two ways, okay? It's an answer. So to answer this question, I can answer it in two ways. The first way, I can use these opposite angles. So we normally say the opposite angles of any quadrilateral, if when you add them, they are able to give you 108, it means that quadrilateral is cyclic. So you can see now, if I say 150 plus 130, I will get 180, is it? So which means here, a first way to answer this, I can say, when I take angle Q, I add it to angle R1. R1 is this one. I'm able to get 180 degrees. Meaning, therefore, quadrilateral TRFQ is cyclic. Is a cyclic quad. Let me say is a cyclic quad. So the reason it's a cyclic quad, it is because it's a converse of a theorem that says opposite angles of a cyclic quad are supplementary. This is P, yeah. It's a converse theorem of a theorem that says opposite angles of a cyclic quad are supplementary. Okay, so the converse says if the opposite angles of any quadrilateral add up to 1/8, then the quadrilateral is cyclic. So that is the first way to answer this question. Remember, when we are using the theorem without the circle, the reason we say it's a converse. And then look at this one now. Another way. This one is method number 1. Okay. Method number 2, I can use the exterior angle of a cyclic quad. Ne? So method number 2, I can use the exterior angle of a cyclic quad. So I'm using a converse of this. Exterior angle of a cyclic quad. So this one is a converse because it's a vice versa theorem. So we are saying if the exterior angle of a quadrilateral is equal to the opposite interior angle, then the quadrilateral is cyclic. So if I can prove now that this exterior angle of this quadrilateral, remember this quadrilateral is not cyclic according to the second method. Ne? So I want to prove that. So for me to prove that, I want to prove that angle R2 is equal to angle Q. So we know, first of all, we have to calculate angle R2. I can calculate angle R2 using a straight line, is it? So obvious angle R2 would be equal to 150 because 150 plus 30 is 180. So I can say here, when I'm answering this, I will first say angle R2 is equal to 150 degrees. The reason here, I was using angles on a straight line. Angles on a straight line. We know that they are supplementary. You can continue and say they are supplementary. Okay. So that's there you have it. Okay. And then once I've proven that, now I'm saying this one is 150 degrees. I've calculated it and stated the reason. So which means if this one is 150, even this one is 150. So an exterior angle of this quadrilateral is equal to the opposite interior angle. So which means now I can say, therefore, you can see that angle R2, which is this one, is equal to angle Q. Is equal to angle Q. They are both equal to 150. You can add this one if you want to. Okay. And then which means if these two angles are equal, which means therefore, or I can say it implies that quadrilateral TRFQ, quadrilateral TRFQ is a cyclic quad, is a cyclic quad. Okay, let me write quad here. And then because, this is how sometimes we write because in maths. Because you have a converse of a theorem that says an exterior angle of a cyclic quad is equal to the opposite interior angle. Yeah, you have a converse of exterior angle. You have a converse of exterior angle of a cyclic quad theorem. This is THM. Yeah, so it's a converse theorem. So a converse theorem, if I can able to prove that this is equal to this, it means this is a cyclic quad. Okay. So remember, the theorem was saying in a cyclic quad, an exterior angle of a cyclic quad will be equal to the opposite interior angle. And then the converse theorem now will say if in any quadrilateral like this one, an exterior angle is equal to the opposite interior angle, it means that that thing can fit into its own circle. So in another word, when we are proving that something is a cyclic quad, we are trying to prove that it can fit into its own circle. Okay. So this thing can fit into its own circle. Okay. So that is why what we are proving when we are proving if a quadrilateral is a cyclic quad. So there are two ways to prove in this case. Then there is the last one, which is the other theorem that I will do on another video, because I don't want to mix the videos. So I will be doing the last video of another theorem, which is still theorem 5, but it's another theorem of theorem 5. So I'm done with this one.